Hello everyone, welcome back to the video session concerning probability of independent events. Actually, independent events are defined to be events such that the occurrence of one event does not depend on the occurrence of another event. These two events actually they have to be independent in the sense that the occurrence of one event does not depend first on the occurrence of another. So every event occur independently. And why this happen is because the two independent events, they are coming from two independent experiments which are actually different, or which actually does not depend on one another. What does this mean actually? One experiment, if it happen, does not wait for another experiment, or for the first experiment to occur first. So every independent will occur independently without depending which experiment comes first, comes last. But at the end of the day, the events also will be independent. So basically, today we want to check those kind of events. So far we've discussed about events which come from the same experiment. But today is about events which come from two different experiments, or it might be same experiment, but they do not depend on one another. That's a necessary condition that will lead to understand this independent event. And if we know what independent events mean, now it will give way for us to define or to understand the issue of probability on these independent events. Let's check an example of situations where we can now say that these events are independent. So for example, so let's say you have so check these events actually. This E1 is the event that head will occur after tossing a coin. And this event E2 is the event that odd numbers 1, 3 and 5 will occur after rolling a die. So you can see you have got two experiments. One is for tossing a die and another one is for rolling. The first one is for tossing a coin and the second one is for rolling a die. Now these two experiments, it happened that these now are the events coming out of those two experiments. And when you roll a die and you toss a coin, the event that heavy will appear, it doesn't matter, or does not depend on whether odd numbers will appear from rolling a die or not. So head will appear independently without caring, without maybe waiting whether a die will give a result like this. So the two events will occur independent without depending on one another. This kind of event, E1 and E2, are independent. So in real life situation, there are a lot of kind of events which we can say they are independent, coming from two different experiments. Another scenario I can say that maybe you as a student, the event that you will pass your mathematics test does not depend on the event that your friend will study hard. Why? Because there is no interaction there. If your friend is studying hard, that means your friend is going to pass on his own. And yourself, if you don't push hard, you are going to fail on your own. So things does not depend on one another. So you passing mathematics testing is just you and you. It doesn't depend on your friend's effort. That kind of situation, I think it will help you to understand these independent events. So what next is to break down or to analyze the formula that is always used to find the probabilities when it comes to two independent events. Let's check what's going to happen next. Now generally, if A and B are two independent events, suppose A and B are two independent events, then the fact is that the probability of A and B occurring together, the probability of A and B occurring together is given by the probability of A times the probability of B. So this is now the formula. You have to use to find the probability of two independent events. So our interest is to see the chance that those two events will occur together even if they are independent. So we want to see the probability of two events occurring together, both A and B. So the probability is given as a product of individual probabilities. The probability of A and B together is given as the product of individual probabilities. So this is just the formula you have to take, and derivation or proof of this formula for your level this time I think is out of the scope for this time. So I'm sorry to not verify this formula how it came from, but we need to do a couple more of examples to see now how we can apply this formula. Let's check. With example number 1, the question says the probability that a student pass mathematics is given to be 2 out of 5, and that the same student, the probability that he pass mathematics test, chemistry test, is 4 out of 7. Now find the probability that he pass both subjects. So here now, this question is talking about a student doing two different tests. First test is mathematics test, and the second one is chemistry test. Actually, these tests represent experiment. That the student is doing two different experiments. Experiment on mathematics and experiment on chemistry. So the probability that he pass mathematics test is given there, and also chemistry is given there to be 4 out of 7. The question is asking to find the probability that he will pass both subjects. So here actually what is being asked is the chance that both of the tests will be passed. Now, in order to answer the question, you have to suggest the symbols. So, suppose P of M represents the probability that we pass mathematics, and suppose this P of C represent the probability that he passed chemistry. Now, here now you have given the information that the probability that he passed mathematics is equal to 2 out of 5, and the probability that he passed chemistry is given to be 4 out of 7. Now, what the question asks you is to find the probability that a student will pass mathematics and chemistry. So both this word both is now representing a set word which is symbolized as ending, is considered to be ending, and in the set form we write probability of M intersection C. So this is what the question asks you, that what is the probability of M and C. Now, because these probabilities are coming from two experiments which are actually independent, because a student passing mathematics does not depend on whether he passed chemistry or he failed chemistry, and also the opposite, that a student passing chemistry does not depend on whether he passed mathematics. So actually that is what we expect, by the way. So these two events are independent, and therefore you are free now to use the probability of independent event. Now the formula, so we say from the formula probability of M and C, this becomes probability of M times probability of C. So what you do next is to plug the information given, plug these values, and that's it, you kill it. And then this becomes 2 out of 5 times 4 out of 7. And if you multiply these fractions, you get 8 out of 35. 8 out of 35. This is now the probability of M intersection C. So actually we've seen this, that the probability of M intersection C is 8 out of 35. So this becomes simple as that. What you need to do to make sure that you answer the question correctly is to ask yourself that the event coming from two independent experiments. If they are coming from two independent experiments, that means the two events will be also independent, and therefore you'll be given a green light to use the formula for independent probability or independent event. Thank you. Let's check the second example. Now example number 2 is about Mary and John who went for an interview for a certain post, maybe for a certain job, but what we know that Mary and John went for a particular interview from a certain companies, I could say. Now the probability that Mary passed the interview is given to be 7 out of 9, and that of John is 5 out of 7. Now find the probability that A, both passed the interview, B, only Mary passed the interview. So this question again is about interviewing two different people. So actually you can see, or you can ask yourself that if John failed the interview, or if John passed the interview, does it affect Mel? Or if John failed the interview, does it affect Mel? I think no, because everybody has got his or her own chance of passing. So we can say, or we can conclude that these probabilities are coming from two different experiments. An interviewer will have a chance of picking Mary, or will have a chance of picking John. Therefore, these chances are independent. These chances are independent, does not depend on one another. Now, so we can say here we are given the probability that Mary will pass the interview as 7 out of 9, and the probability that John will pass the interview to be 5 out of 7. So now, to find the probability that part A, that both will pass the interview, this means the probability that Mary and John to pass the interview. This means that probability of Mary intersection John. And remember this one, we have to interpret to be the product of probability of Mary passing times the probability of John passing the interview. Why do we multiply this? Because we are sure now the events which is concerning with these questions are independent. So this formula now works for you. So this becomes 7 out of 9 times 5 out of 7, and you'll get 35 out of 63. So this now is the probability that both of the people, Mary and John, are passed the interview. 35 out of 63. Okay, part B of the question. Part B of the question. Part B of the question is asking that to find the probability that only Mary will pass the interview. Remember, if Mary passes the interview, at the same time John will be failing the same interview. So this one means find the probability that Mary passed the interview and John failed the interview. So we have to put dash here, because this dash means not for John. So Mary will pass, but John will not pass. So this one will mean the probability of Mary times the probability of not John. Now this one is a complement probability of complement event. A probability of complement event. Now you can remember the probability of complement event. If you make this, it becomes 1 minus probability of John passing. So now you have to plug the values, and this becomes 7 out of 9 times 1 minus probability of John passing is given to be 5 out of 7. Now we have to do this math by simplifying. So if you simplify this mathematics,
a new SMS from Afia Corona.
If you simplify this mathematics, the probability of n intersection J naught will be equals to 35, not 35, the probability will be equals to 14 out of 63. So I'm saying after simplifying this mathematics, you have to get this answer. And this represents the probability that only male will pass the interview. At the same time, John will be failing the same interview. Thank you. And I think this is the end of this session concerning the probabilities of independent events. Bye.